Hi, Dr. Revis here. In this brief lecture, I will show you how to carry out a gravimetric analysis calculation of an unknown that was formed in a precipitation reaction. In other words, we want to carry out a calculation that allows us to analyze the results of a precipitation reaction to help determine how much of the chloride ion was in an original unknown sample. And here is the problem. A 0.566 gram ionic sample containing chloride ions and an unknown metal is dissolved in water and treated with excess silver nitrate. The purpose of the silver nitrate was to precipitate out the chlorine from the unknown sample. If 1.0882 grams of the silver chloride precipitate is formed, what is the percent by mass of chlorine in the original compound? In other words, when the silver nitrate was added to the ionic sample containing chloride, silver chloride formed as the solid product. We can consider the reaction to look as shown here. Note, however, we don't really need this reaction to solve this problem, but it's just worth taking a look at it. Here we have the original metal complex with chlorine in it. We add the excess silver nitrate. The precipitate forms as silver chloride solid with the spectator ions of the metal and the nitrate remaining in solution. Now, what we can do then is use percent chloride divided by the original sample to get the percent chlorine in the sample. However, we don't know the mass of chlorine. Therefore, we can, if we think this through, we find that we can use the mass of the known silver chloride to calculate the percent chlorine in a standard silver chloride compound and use that information to back calculate, if you will, the amount of chloride in the ionic sample. All right, so here we go. We can calculate the mass of chloride ion again if we know the percent by mass of chlorine in silver chloride. That's the key. Let me repeat that. If we know the percent chloride in a known silver chloride sample, we can then use that information to calculate the amount of chloride in the unknown. So step one here then is to calculate the amount of chlorine in silver chloride. And that's a theoretical calculation. So to do that, we simply take the molar mass of the chlorine and divide it by the molar mass of silver chloride. Here we show you how to calculate the molar mass of silver chloride. We say times 100, and what we discover is we have approximately 25% chlorine in a standard silver chloride sample. And that's what we have in this 1.0882 grams. So in this 1.882 grams, we have 24.72% chlorine. So we could then use the decimal value of the chlorine times the mass of the silver chloride, and what we find is that 0.2690 grams of chlorine were in this particular sample. That 0.2690 gram of chlorine in this silver chloride sample came from the original ionic compound. Let me repeat that. The percent chlorine that was calculated from the silver chloride precipitate came from the original sample. Therefore, if we take that mass from the silver chloride calculation, which equals the chlorine in the unknown sample. If we take that and divide it by the mass of the original sample times 100, we discover there's about 48% chlorine was in the original sample. So that's how we carry out these problems. Essentially, we take the precipitate value and obtain the percent of the ion, in this case chlorine. We then take that percent times the mass of the precipitate to get the mass of the chloride ion. We then take that chloride ion in step 3 and divide it by the original mass of the ionic sample times 100, and we get the percent chlorine. So the percent chlorine in this reaction, in this sample, is about 48%, 47.51%.